Okay, so we're going to just review the color theory of light because some people find it a little difficult. The gizmos are really good, but if you didn't get your head around it, I'm just going to go over a few things. So, the primary colors of light. Now, you probably noticed when you were doing this on the gizmo that mixing colors of light does not work the same way as mixing pigments like you did with paint when you were in kindergarten. So we're going to start with our three primary colors of light, which is red, blue, and green. So when you combine these three colors of light, you get white light. And white light is just the light we see with. That is the light coming from the sun. The white light is a combination of these three primary colors, but can be further divided into Roy G. Biv: red, orange, yellow, green, blue, and violet. So, but these are the three primary colors. These three colors of light come together to give white. And when we mix those three colors of light, we get white light, which is in the center here. If we were just to take the blue and red light, they will combine to give kind of something that feels logical, which is magenta. Okay? When we mix the green and blue, we get a logical color called cyan. Now, this isn't a true cyan. I don't have one on with this software I'm using. The odd one I always found is when you mix red and green, you actually get yellow. And that's how you know this is just weird. We're mixing light here, not pigments. Obviously, red and green aren't going to give you yellow. If you're mixing pigments, they give you some kind of ugly brownish color. So when we take all these colors and combine them, we get just basic white light. So that's in the middle. So we need to understand how additive color theory works when we're dealing with different colors of light to make sense of the subtractive color theory, which tends to be a little more difficult. So we're going to take a look here. So I'm not going to recolor. I have this already done for you. So you're going to color your subtractive theory in. You do have to have these colors memorized to make this go smooth. Obviously, for your case, even when you're doing assignments and tests, you have this stuff available to you. But for it to make sense, it just helps to have them memorized. So we're going to look at the subtractive theory now. And basically, what we need to look at is what happens when regular light strikes colored objects. So when white light, which we know is a mixture of multiple colors, the primary ones being red, green, and blue, when white light hits and reflects off of objects, the pigment or the color of the objects dictates what light is reflected off, what wavelength of energy bounces off of it, and what wavelength of energy or color is absorbed by it. So sometimes this confuses people. So we're going to start simple. Let's look at a red rose. So if you look at basic white light hitting a red rose, and you have to understand white light is actually a mixture of blue, green, and yellow light combined. When blue, green, and red light combined hit a red rose, the color that we see is red because only the red light is reflected off and into our eyes. So the colors we see are literally the colors that are the colors of light that bounce off the object and are not absorbed by the object. So our brain perceives a rose as red because the red wavelength of light bounces into our eyes and the green and the blue is absorbed by the rose. Okay, so that's every color we see is just a matter of which colors are reflected off of an object and into our eyes. Okay, so when we say a rose is red, it's actually reflecting red light and absorbing the other colors. So I have a question for you. A red rose would look, what color would a red rose look if green light only was bouncing off of it or being absorbed by it. You have to think about that. If we just shone a green light onto a red rose, what color would we perceive that rose? And the answer to that is it would look black. And the reason for that is there would be no light rays reflected off of it. The green light would be absorbed by the rose, and so we would perceive that as black. So hopefully that helps you understand a bit. So the subtractive color theory of light states that colored matter selectively absorbs different colors or wavelengths of light. Colors that are absorbed are subtracted or removed. They're absorbed by the pigments, so we don't see them. And the reflected light is seen by the eye. Okay, so again, this example is showing white light made up of red, green, and blue bouncing off or hitting a blue object. These two colors are absorbed by the blue object, or in essence subtracted, and only the blue light is reflected off. And we go, oh, that is a blue shirt, or that is a blue sky. That's the way it works. So some interesting facts. Black objects absorb all colors of light. So when we perceive something as black, we say it's not really a color. It is actually the absence of color. So if you see something black, it's the absence of color. So if we think about this logically, today is, 30 degrees and sunny out. Would you choose a black shirt to go out for the afternoon today? And you wouldn't, because we all know if we wore a black shirt out today, we would be really, really hot. And the reason is when the white light hits your black shirt, and remember, light is energy. So we have white light made up of green and blue and red light, or green and blue and red energy, the wavelengths of them is the actual energy. Instead of bouncing off your black shirt, they will be absorbed by the black shirt, and nothing will be reflected off. And since the energy is being absorbed by you, because it's going into your black shirt and then obviously into your body, you get really hot because you're absorbing the energy from the sun. If you wear a white shirt, so here we've got the three primary colors of light. So white light, which is made up of green and blue and red, hit your shirt. Those three colors of light are reflected off of your shirt. Nothing is absorbed by your shirt. So you're not absorbing any of the energy from the sun, and hence you're not as hot. You're cooler than if you wore a black shirt. And really the difference is quite huge. Are you absorbing energy or are you reflecting it? On a hot day, you want to reflect it. So just some information. Your primary subtractive colors are magenta, cyan, and yellow. And your secondary subtractive colors are blue, green, and red, which are the primary of light. So if we look at how white light shines on a cyan pigment, okay, so again, we're going to start with your three primary colors of light coming in, which is just white light. Why do we see cyan? Well, now you have to go back to your additive color theory, right? What two colors of light make cyan? Well, the two colors of light that make cyan are green and blue. So if we see cyan, those two colors are reflected into our eyes. Now the red, which is part of the white light that's shining on that cyan pigment, is absorbed or subtracted away. And then we're just left with the green and blue wavelengths. That's why we see cyan. Let's try white light on a magenta pigment. So again, you put the white light going in. Your three primary colors, red, green, and blue. And the green is subtracted or absorbed. And the fact that we see magenta must mean that the red and the blue, because that's the two colors of light that come together to make magenta, are bouncing back into our eyes. and white light on a yellow pigment. Again, we need to know our additive theory. We need to know how different light colors combine to get yellow. That is a combination of red and green light, which again is just weird, but that's the reality. So those are the two colors that will be reflected. We see yellow, so the one that's subtracted away or absorbed is the blue. Okay, and we can keep playing with this. We can have yellow pigments and just shine one or two colors of light on, and you have to really think about it, and you have to go back to your additive theory. And some people really, this stuff really clicks with them, and some people it doesn't. So if you're struggling with questions, just ask, and I have a worksheet for you to just practice and upload. I just want to see how you're doing.